main purpose, in its simplest form, is to look at an explosion underground and look at the craters that we can form, disruption in the subsurface, and the deposits that we can produce. We also collect the samples, so there's also more typical geology where you collect rock samples and you look at the grain size, and we look at the different colors of the material because we colored the subsurface. Our gravels where we did the experiment are colored so that we could tell from what depth the ejecta came from. So how does changing the position of the charge, where the explosion or eruption is occurring, how does that affect the deposits at the surface, the crater, and the subsurface? So it takes a lot of people to make this experiment happen. We have a lot of collaborators. We have several international collaborators. I believe we had 6 institutions represented last year. So 11 different visitors come in and they all bring their own instrumentation. So some of them bring different camera types. We have high-speed camera and infrared cameras and high-definition video. And we also have geophone data, so ground shaking data that we can collect through seismometers, and infrasound, which is actually disruption in the atmosphere, so it's a type of microphone. We were also interested in the velocity of particles that are transported by the explosion. And one of the tools that we used was actually a series of ping pong balls and tennis balls that were filled with different density materials. So we could say a ball of a specific color had a density at the time of the eruption, and then you trace the particle using video, and because they're bigger and obvious colors, they're easy to track, and then we can detect where they landed. So we can compare the initial instantaneous velocity resulting from the explosion, and we can see the travel distance of the ballistics, and we can use that to help calibrate models of particles that come out of volcanoes and use them for hazard assessments. The most exciting part of the experiment is pushing the button and making the ground explode. The most exciting science part of the experiment is that it's an integrated data set. So we have data collected with all these different instruments, and we have the above ground data, but we also can look into the subsurface. We can dig into the deposits, and then we can compare them all together. So at a volcano, a real live outcrop, you only get part of the story. You either see the deposit after it's happened. Sometimes you can see the process and the deposit if it's at the surface, but anything that happens in the subsurface we don't see until thousands to hundreds of thousands of years later when it erodes. And so you only ever get snippets of the whole story of a volcano. So what our experiments give us is this opportunity to look at the entire story from start to finish, and it erupts on time, and it erupts the size that we tell it, and it's a very convenient way, and it's a unique opportunity to study the system and its completion.